I'm Uwe Schindler, and I've been working for 40 years with ZALF. ZALF is the Leibniz Center for Agricultural Science in Müncheberg, Germany, where scientific research has a long tradition. I'm working as a soil hydrologist in the broadest sense. Doing this kind of work, I have mainly promoted methodological developments. Looking into a chemistry lab today, you will find cutting-edge technology products as far as the eye can see. If you do the same in a physics lab, you will see devices that are 50, 60, 70 years old, and the methods applied there are partially 100 years old. The reason is there's no industry pushing things forward. That's why most labs, or almost all in the world, are working with devices that are completely obsolete, highly imprecise, and the measurements need much time. For us, this was the reason to think about doing things more effectively even 25 to 30 years ago. Of course, colleagues from the Netherlands lead the way. Wind developed the evaporation method in the 60s, and we investigated this method. But we couldn't use it, as it needed 5 tensiometers and a computer and iteration processes, and all the bells and whistles that weren't available for us in East Germany, where I'm from. So we tried to come up with a process that was more easy to handle. Finally, the evaporation method was called the simplified evaporation method, and it was publicized in 1980. It provided the basis for measuring the soil hydrologic characteristics, water retention function, and hydraulic conductivity simultaneously, and quite easily. After Germany's reunification, I got in contact with the colleagues in the West and found out UMS had cool tensiometers. They could measure even beyond vacuum. That means up to 1 or 2 bars or even further out. And of course, this was a potential that we could use to improve the evaporation method. It's important to know this method, regardless of which type, has 2 important disadvantages. First, it demands a great deal of weighing precision, and second, this is crucial, a large measuring range. In the past, this range was limited by the tensiometers. Now that we had the new tensiometers, I talked with the UMS guys and asked them, shouldn't we work together on a few nice things, maybe design a device? UMS took up the idea and an intense cooperation developed that resulted in a device called HYPROP that entered the market in 2008. The evaporation method enables measuring, or let me put it this way, determining the soil hydraulic characteristic values, that is to say, the water retention function and the hydraulic conductivity. In cooperation with UMS, and using this device that entered the market in 2008, we gained new knowledge, so that we are now able to measure from the saturation to the permanent wilting point. Today, we can measure it with one device. Usually, you would need 4 for this. We can do all this with a better quality in a shorter measuring time. And it's finally a smart soil hydraulic toy, as you can do a lot more than determining these characteristic functions with this device. Usually this is done for rigid soils. We can do this for dynamic conditions, and we can consider swelling and shrinking. Additionally, we can consider hysteresis. All this can easily be done. Usually you would have to buy and use very complicated machines that cost a lot of money, time and effort. Eventually, all this is possible with HYPROP. This will become the device of the future.